All right, good evening. So, like before now, we agreed today we'll be using today to do some catching up, kind of try to go over what we've done before and entertain a lot of questions. So we'll be able to clarify some stuff that people might be having misconception with, or maybe what you we've learned that you didn't really get very well, or you're still struggling with. So I wouldn't know if we have questions. It's just time for us to ask those questions on some areas that we need to, because we can't just start all over again and treat the whole stuff we've treated. So it's mostly based on where people are having issues.
Yeah, I have a question. I'll begin with a question, sir.
All right.
Okay. I created my database. I created the tables. I did my assignment, but I was kind of confused at a point where I don't know if I can share my screen and show you where I was confused. I did not really understand the language, but I did it to
Okay,
all I.
maybe you should do that. So what happens is like if anyone has question and any of us, like aside me, if you know the answers to those questions or you know how to better explain to us, let's make it more like conversational.
Yeah, that's fine. That's better.
Yeah. So you can share your screen. Let's see where
Okay,
exactly you have it.
okay, sir. Okay, can you guys see my screen?
Not yet. Let me stop sharing. Okay, yeah, we can see it now.
Okay, this is where I was confused. This one I'm highlighting now. This
Yeah.
user ID, then integer identity. What I don't understand here is after the integers, I don't understand this ID and then this open parenthesis one one then primary key. Primary key like this first statement. I don't really understand it.
All right. So from there, let me just you can I like what you did is tactically correct, but for the sake of aesthetics, like the beauty of your code, once you step
Yeah.
into these brackets, it's you can just do tab, like shift everything one tab space to the right.
To the right. Okay.
Yeah, yeah. It's not like everything you did is correct, but no. You just return that one.
Yeah.
Mm. But I think you've deleted. I don't know if it's
No,
yeah,
it's okay.
like this way. Okay, it was just four columns.
Yeah.
Mm. So what you did with that idea, I that day when I was showing how to do it graphically, I forgot to also point out this. When you make when you add this identity constraints, what
Yes,
it
sir.
means is, yeah, you would have seen it in action when we start inserting data into this table. So what this does is, even if you don't give, in fact, if you give a value for this user ID, is going to give you an error, because what you say here is, I want you to start from one and take the step size one. Like each time you add an entry to the table, it should
Yeah.
just auto fill this user ID for you. You don't want to be in control of that user ID. You just want it to be auto generated, and you want it
Oh,
to start from one. So the very first insert you're going to do, or the very first item you're going to put into the database, will take the value one for user ID. The second one is going to take the value two. The third one is going to take the value three, and it continues like that. If you
wow.
change this to, yeah, maybe zero one, that means the first entry you're going to put there is going to start
Be
from
zero.
zero.
Yeah.
Yeah.
Then followed by
So
one.
whenever, yeah,
Mm. Yeah, I think in addition to that, if you if you have a 1, 2, so it means the first one is 1, then the next one will be 3, the next one will be
yeah,
5.
yeah.
Yeah.
So, but
Okay.
what happens? What happens if a row is deleted? Like, let's say we have one, two, three, four, five. 6, 7, and you perform an operation that deletes row number 3. If you want to insert the next one, what happens? Will it fill up the space or it continues from, let's say we stopped at line 7, ID number 7. Is it going to continue from ID number 8 or will it come and fill up the one you deleted first?
I think it's going to continue.
Okay. So that's exactly what happens.
Okay,
It
I get
continues,
it.
it doesn't come back. Yeah.
I get the point now. I get the point. I get the point.
Yeah.
Thank you so much, sir. I think my doubts have been cleared.
Yeah. That's what it does.
Okay, okay. Thank you very much, sir. I think that's all for me. That's the only thing I was doubting about, but everything is okay up to this stage.
Yeah.
Okay, thank you so much,
So
sir.
let's
Thank you.
get, yeah.
So I'll leave the
Let's
floor
get
for
more
another
questions.
person.
Yeah, yeah, yeah.
Yeah, good evening, everyone. Hello?
Yeah, good evening, boss. Welcome.
Okay, see, the last class, I wasn't too much available. I came in late and I went off late, early as well. So all of these things I really don't understand. And I don't want to drag the whole class back again to start from beginning. So I'm thinking and I'm hoping that maybe as time goes on, I will catch up. Then the video, the audio recording of the last class, will that help as well? If I go through it, because I was trying to go through it to the earlier in this film itself, but I've not gone through it entirely. So I don't know how I'm going to catch up with the class now.
All right, you're welcome, sir. What happens is, like you already said, the solution is that watching those videos and trying to go through the resources we provided. Just go through the video. If you have any question, you should ask here. But I think like today, because mostly what we are doing today is we are discussing what we already learned. So you would have been able to make more contributions if you had gone through the video and resources.
Okay. All right.
Yeah.
Thank you very much.
Okay.
Yes.
So I don't know for others because if we are being quiet, that means we should just carry on with new concepts. If you have anywhere, maybe there's a demonstration I would like us to go through again. You can just point out that while we're doing this, you were not able to pick everything we did. Could we just briefly go over it and explain some stuffs? Then we'll go then.
Yeah, I think if I can peep into so many people's mind, they are just in the same position with the last guy that just spoke. They don't even understand what to ask. They don't know where to start from. So if there will be any way you can do some form of recap, but I know that while we progress, we'll be touching those things we also did previously. So I think it's just for them to pay attention and understand it better this time around.
Hello,
Okay,
good
on that
evening.
note, yeah, good
Sorry.
evening.
Yes, good evening. Okay, so I was actually going through the chats for the last time, and the only thing you dropped because
Good evening,
I
House.
as well did
Please, I
not
have a
meet
question. I
the
don't know if
class.
anybody can attend to my question, please.
Okay, so sorry, if someone is already talking, let's just hold on for the person to finish.
Okay, so as I was saying, I said I did not really follow up last time as well. But the only thing you dropped on the group was like a slide of what you used. When I checked the slide, this demonstration the other guy showed is not in the slides. I was like, is there a video? And perhaps I missed the video for the last class so I could at least see the demonstration of what this guy did and then perhaps follow suit. But It's just the slide I'm seeing that you actually posted on the group here.
Yeah, we have a YouTube channel for this platform, not just
Okay.
for the data science. Yeah, if you go there, you see a lot of other videos from how to set yourself up, installations, and the rest of them. Yeah, maybe we'll
Oh,
still share the link to the this thing. There's also a book I recommended. I dropped the PDF on the platform. The other resources we'll be using, but I don't just want to overwhelm you with resources because I realized myself, if I have too many resources, I'll read this and I would like to go and compare with the other one. I end up wasting my time. So I'll still provide more resources as we go. But for now, we have the videos. We have.
Please, we can't hear you.
Hello, can you hear me now?
We can
Hello.
hear
Yes,
you perfectly. We can hear you, sir. If you're
Yeah,
not
yeah.
getting him,
Okay.
then you have a problem because you can hear him.
Okay, so that's just it.
We can
Maybe
hear you
after
clearly.
this video, you just check, yeah, you just check the YouTube channel. You see, I think the video is up to 2 hours plus. So, like, maybe while we are not seeing those questions, maybe I will just briefly go over what we did, and whoever
Sorry,
has
before we
questions.
go over it, please, I have a
Okay,
question.
okay, yeah. Sorry. Okay.
The slide you sent to us, I think I worked on it, but if I want to go back to my that page, that code, so how can I get to it? I've already saved the tables I created, so I want to go back to that interactive page where I can see all the code and everything.
Okay. Today I'll be showing you how to save your code today. We'll still do exactly what we did. In fact, after writing your code, if you want to save it, just do Control S. That's all. If you do Control S, there'll be a prompt for you to choose where you want to save it. So just know where you're keeping them. You could create a file on your desktop or wherever you can remember. Name it whatever you can
Okay.
remember and be saving your codes there. Whenever you just locate those files, click open it. It will open the database manager, the management studio for you. Yeah. So I don't know. Do we have more questions, or I should just briefly go over what we've already done with the same slide we? All right,
We
let me
can
do that.
continue.
Yeah. So what did we say is a database?
Okay, I can answer that. A database is the organized collection of data for specific purposes.
Yeah. So that's correct. Do you have any other definition? So we said the database is just a collection of records for any purpose. It could be just for us to know, like for reference purposes. It could also be for us to make decisions. It could also be for us to analyze. Like if you go to the bank, you find out all the tickets you're filing. Each time you make withdrawal, they file those tickets somewhere. They file both the hard copy and of course the system records the soft copy, like your activities in a database, so that whenever you want to know all your activities, you can go and query the database. You just ask them that you want to print your statement of results. Though those customer services don't really use SQL to print the cost this thing. There are some codes that are already written such that they just give their query parameters with or without knowing that's what they are doing. But there's a code behind whatever they are doing there that actually issues this same query we are doing, spooling up your own record, just your records, with the restriction of how you've defined. Let's say you just want to have your last 2 months uh, record, how your activities of spending. They could just give the parameters, and indirectly something triggers a query to the database which fetches your activities and is given to you. So once we start keeping records, it's already a database. if we want to be keeping record, let's say in a church, we want to be keeping, or maybe we have a levy and want to know how many persons have paid, we can actually ask our maybe FinSec or whoever to please be, whoever pays, just write his name, his phone number, is where the person is coming from, and the amount he paid for record purposes. So once you start collecting recording events, you already have a database. The register we used to have in school is also a database. Like, there was a reason I asked the guy that demonstrated what he demonstrated. If we delete an entry, do we go back to refill that entry? This thing is just following exactly what we used to do in school. In school, we realize if a student drops or changes school, it doesn't now mean that the next students coming or that every other person readjusts their number. If we have number 1, number 2, number 3, up to maybe number 37, and by chance, someone in number 18 changes school, we don't start readjusting. Maybe 19 now becomes 18, 18 now becomes 19. It continues the way it is. If the next person comes for enrollment, we assign the person another number from where we stopped. We don't go back to that. That's exactly how our databases also work. So that was our discussion on databases. Then we are trying to, because we'll be using this application, this software, which is a SQL Server, for the duration of this our learning. We are not going to be writing our records on paper. So we are trying to kind of discuss the structure of relational databases, because SQL Server happens to fall under relational databases. We have NoSQL databases, which means not only structured query, like not only SQL databases. What that means, if you decide to structure your code or to structure your tables in a relational database format, you can still do it there, but that's not the only permitted way of building your database. So mostly those are used for deep learning. When you advance in your data analytics or data science program, we might not be getting to that point in this distance. You now see we have options. People do natural language processing, which is what gave birth to our ChatGPT. Is ChatGPT, the whole idea of artificial intelligence is just from data analytics and data science. So you now start seeing options. People want to go into machine learning engineering. People want to specialize in their diverse fields. So we said SQL databases have this structure. We said the relational databases, which is what we will be using, are structured in tables, rows, columns, and relationships. So let me still ask again, what did we say are tables? Maybe some other person can just answer. I know we all know this thing, but I want us to make it like conversational. We define tables then. Hello? Hello, can you guys still hear me?
Yes,
Okay.
sir.
Yes, we can hear you, sir. We can
In
hear you.
simple term,
What's the table?
in simple term, a table contains rows and columns.
Yeah.
Yeah.
So a table contains rows and columns about a particular set. Let's say we want to track the set of staffs, or let's just say we want to keep record of our staffs. We can decide to throw their details into a table called staff. We want to track our customers, we can throw that into a table called customers. We want to track, maybe we just want to levy some persons and want to collect money. We can just say, levy for this. We can name our table anything, just a collection of a set of observations. So here, the set tables are the main structures in databases. Each table always represents a single specific subject. Like I said, we can want to, maybe we just want to keep record of our staffs. So it's a specific subjects. If you're keeping record of your staffs, it wouldn't be nice if we now see maybe you recording stuff like transactions in where you are recording the staff's details. So a table should just address one specific subject. If you're keeping record of staffs, or you're keeping record of orders, or you're keeping record of maybe how many vehicles we have in our company, we'll put them in a particular table. So those tables are structures. It's just like what we already know. I think I made some screenshots somewhere. Just the way we know tables in our normal secondary school or high institution classes, that's exactly what tables are. Let me trace. There was a screenshot I made somewhere. I was thinking it will help us still drive that point home. All right. So, like for instance, now that's the screenshot. If we want to keep record of houses, this is a real estate company or a real estate whatever. So they are listing houses, and inside these houses they are listing, like within the houses they are listing, what is important to whoever is listing it is one, the price, two, the number of rooms contained in this house, and the area, that's the area it covers per square meter. So you see, pictorially, we have house number 0. Of course, this number 0 indicates what? The primary key. That's the ID to this house. We have house number 0, we have house number 1, we have house number 2, house number 3, house number 4. Our own, we decided from that code we wrote, we decided to start from house number 1, not 0. So this is the pictorial display, but you might not throw this into your database. If you want to have a database that will just represent exactly what we did, we can have something that looks like, you just draw a table, house, price, room, area. This house is the primary key. You see, we saw house number 0, house number 0, house number 1, house number whatever. So what this house indicates is just the primary key, how we can identify them. We will now say column for price, house number 0, the price for house number 0 is $115. Then it has 4 rooms, and this is the area it covers. House number this. So it's just a way of putting things in tabular form. Then this, if you're traversing the table horizontally, that's you're moving from here. If you pick house number 0 and you traverse it horizontally, or you move along the horizon, you just move this way. What you're moving along is called row. So this is called row. This is row number 2. This row number 2 has record for house number 2, right? Row number 3 has all the records for house number 2, and so on and so forth. So these are just observations. It could be houses, it could be staff, it could be students, it could be others or other activities or sections. Now, if you're moving vertically, what you're tracking is called columns. So what a column does is it talks about a particular feature or a particular property or a particular, like house number 1 has, like from the way we listed it, we saw that house number 1 has price, it has room, it has area. House number 2 has price, it has room, it has area. Same thing with house number 3. So if we decide to document them, although if we also want to put images, we can put images there, image files there. So it just depends on how we. So from this table, all we have is what? If you come to house number 0, when you want to trace the price, you just move along this point until you meet the column price. So whatever you have is the value for the price for house number 0. If you move further, you meet rooms. So this tells us the number of rooms we have in house number 0. If you move, it tells you the area it covers. So basically, what our columns are talking about are the features of our observation, like we are using properties. The features of those houses, the price is the price. Once you travel, you see the price for all of them. Once you travel horizontally along this price, if you travel vertically along this room, you meet the number of rooms in house number 1, number of rooms in house number 2, number of rooms in house number 3, and so on and so forth. This is a zero-based index, like counting from 0, behave like it's a long-standing tradition that programmers don't count from 1. So you might, as you start, like now that you started, you might be seeing that programmers don't like counting from number 1, number 2, number 3. They will say, if you didn't see the way I prepared our 0 lesson 1, so that's just how. But that does, you can defy it if you wish. But if you defy it, you're going to pose some surprises to other programmers, because they think that way. So when you have house number 1 as your beginning points, you'd be surprised people will be looking for house number 0 as long as it's programmers. So now all these the horizontal tells us about the rows and the vertical tells us about the columns, just the way we have our traditional tables. But this place we cycled, each of the cycles tells us about the value. Like the value for house number 0 is whatever we have here. The value for room, this is room 4. So we have 4 rooms for this. It's just wherever this row matches with the column. If row number 0 matches rooms, you now say number of rooms for row number 0 is whatever value you see there. I don't know if that helps. I don't know if that helps.
Yeah, it's very clear.
Yeah. So we have rows, we have columns, we have keys. So when we are discussing keys, we said we have primary keys and foreign keys. Primary keys are just a way for us to identify uniquely. When we say uniquely, it means we can't have, just let me pull up that table again. Let me pull up. So if we are saying uniquely, it means under this primary key, under this place we've decided to be our identity key or primary key, the way we can identify each record, we can't have 0, 1, 2, then we have 0 here again. It must be unique. It must just be unique to that observation. So 0 is unique to this observation, this house number 0. 1 is unique. If we see 0 or 1 elsewhere, then we have defined that uniqueness constraints. It's no longer unique. So if we decide to assign a unique, it could be numbers, it could be text, it could be whatever, like our account numbers. We were discussing how to save how to store values the other day. And I told you that if you're not performing calculation on any number, it's best to save it as characters. So for our account numbers, if we decide to save them as characters, they are still our unique ID. For every account, there's just one particular account number that is unique to it. So that when you want to make transfer, if you get the account number correct, it will go to the right destination. So our primary keys are just a unique way of identifying observations or records in our table. In this case, we use zero-based index. So house number 0, house number 1, house number 2 is just the primary keys. So for the foreign keys, if we take a primary key from one place and put it in another place, it becomes foreign to that table. I don't know if let's ask questions around this key. I know we have questions. Let's ask questions around this key.
Please, you have to explain more, sir. This is your house 0. Must we have house 0? Can't you start just from maybe 1? And on the account side, you said that we can do it, is it alphabetically, something like that?
Yeah.
So please,
Okay,
can you come?
like house 0, for house 0.
Yeah.
Standing tradition, I made it like that too. When I got to programming, that programmers like counting from 0. They don't count from 1. They mostly don't count from 1. So I was not the one that prepared that document. Someone prepared it. But I'm just trying to explain to you that most programmers, you have come into the world of programming or the world of tech, you are going to see more of this. You are going to see people start counting from number 0, number 1, number 2, number 3. It's just a convention we have chosen to go. So over time, you will also start counting like that.
Okay, let me just add one quick reminder to our question. After 0, 1 is not the next number. We need to know that because there are 0.5, there's half, which is after, which comes before 1. So you have to just have that image in our head that 1 is not always the first thing.
Yeah. So that's that. But when we are counting our whole numbers, integers or counting numbers, there are discrete. Discrete means you can take steps. There are infinitely many numbers. You can't possibly list all the numbers that exist between 0 and 1. There are infinitely many of them. 0 0.0. So these are just approximation. But when it comes to counting numbers, programmers decided to, or conventionally, choose to be counting from 0. 0 to maybe. So if you see, when we write, because I don't know if time will still permit us to do Python. When we start our Python, you still see this when we are discussing lists and other stuffs. Programmers think in zeros. So that's it. So technically, you can just translate this 0 as number 1, just the way we've been counting. Every normal human being counts 1, 2, 3, 4, 5. So in this case now, looking at this, I'm going to tell you we have 5 observations. Being a programmer, and you are also now a programmer, you can also say we have 5 observations, even if we have the last digits as 4. It comes from 0. I didn't prepare this, I just saw it and screenshot it. So for the primary keys, think of it this way. In our primary schools, we have numbers that uniquely identify us, or secondary school. So when the teacher comes in and he wants to do his roll call, he simply calls number 1, number 2, number 3, number 4, number 5. When you hear your number, you answer. So the teacher doesn't necessarily need to start saying, my name is Okomaike. Okomaike, assuming we are 2 Okomaikes, we are 2 persons that have that surname and first name. She's now going to say Okomaike, the one that is fair. And let's say we have 2 fair Okomaikes. She will now start looking for another attribute to describe one from the other. So primary keys are just a unique way of identifying a record. So the record of all students' names or all students' details can be prefixed with these are our primary key, which is just number 1, number 2, number 3. So once you hear number 1, the right student answers. The same thing is going to happen to our database, or the same thing happens to our database. We consciously define primary keys so we can easily reference what we need. It is for our own benefit that we define primary keys, because if I now want to filter out, we can have millions of records in the database, and I want to filter out some occurrences for just a particular record or a particular students, as we are using students. All I need to do is just to impute the primary key, and it will fetch me every other detail about that record. So I don't know if that clears your question.
Yeah, simply put, primary key is just your matriculation number. If you are in the university, every student has a unique identity.
Yeah.
So once they input your matriculation number, automatically every other detail about you pops out. But there is a possibility that someone can answer the same name with you. Even you can even be born on the same date.
Yeah.
And the only way
come from the same local government.
Local government, the same state, anything is possible. But the only way you can be differentiated from the other person is your ID number, which is the primary key.
Yeah. So ID numbers, account numbers, phone numbers, they are unique identities. Apart from your phone number, MTN has other details about you. But if anyone wants to reach you, the person simply calls your unique ID, which is your phone number. When you're doing your registrations, you register your first name, your maiden name, you give your NIN. Nobody's going to call you with your NIN. But someone can uniquely say, I want to direct this call to this person. So that's their own primary key. That's phone numbers. MTN has a database of all the users, all of us. And inside that database, we still have that primary key. So I want you to see the far-reaching, like that idea of primary key is so powerful that you must always define it, because there's no other way for you to uniquely identify a record. We still do it without knowing. Subconsciously, when we want to collect, let's say, like I'm using levy. If we levy people and want to say, number 1, why are we always giving that this thing where we have SN, serial number, we say number 1, you give the person's name, number 2, number 3, number 4. So that's just a way of uniquely identifying how occurrences happen. So let me go back to the slide. If you have questions, maybe some other person still, today we just wanted to catch up. So now we have second foreign keys. What foreign keys do is we just pick a primary key from one table and put it in the other table. It forms a foreign key for us. For instance, now let me use your account in the bank. You have an account in the bank, but each time you have a failed transaction, you go to the bank, they'll ask you to provide what is called session ID. So what it means is every transaction you do, be it across the counter, on the ATM, transfers, USSD, have a unique ID called session ID. So if you go to customer service and you want to, they might ask you, when did this happen? Do you have the session ID? If you're able to give them that session ID, it's easier for them to uniquely identify that transaction, when it happened and how it happened. They'll be able to tell you that it was done on this thing, then trace it and correct it. But if you don't have it, it then means you have to describe that I did the transaction on Friday, between Friday and Monday. They'll now run a query that will fetch all the activities on your account from Monday to maybe Friday, try to inspect them, now ask you further questions to nail it down. You're giving them much work. But if you can just provide that ticket, your session ID, the person nails down immediately to the transaction and understand what happens. Was it on ATM, POS? Was it a transfer or whatever? So once you give that, now secondary key, in the case of secondary key, you see, each time they are keeping record of that session, that activity, they bring in your account number into it. Your account number was a primary key to your account details, but the table that describes all the transactions, that's your account number, has become a foreign key in that table because that one has its own ID, which is the session ID. But inside the session ID, they will see who transferred, who was transferred to. So those are like the account it was transferred to, the account that transferred. So those ones that now came in that were not initially or originally part of the transaction table are called foreign keys because they are not indigenous to that table. They were called into that table. They exist in other tables as also primary keys. So that's just it. You can read up on this to understand what we are saying about foreign and primary keys. Then if you don't understand, don't hesitate to always go on the group chat and ask your colleagues. Some of you already understand this stuff. Ask questions in the group chat. Someone might pick it up and explain to you. If I'm chanced, I will also respond to that. But if I'm not chanced, some of us are already good in at least this one we are discussing. You can reach out to them for help.
Excuse me, sir.
Okay.
Does it mean that secondary and foreign key does it mean the same thing?
They're exactly the same thing. In fact,
Okay.
the professional the name that is more prevalent is foreign keys.
Okay, sir. Okay.
Yeah, it's foreign keys, not primary keys. So once a key exists somewhere already and you bring it into another table, it becomes foreign to that table. It's also needed for some stuff. So we talked about relationships. When we are talking about relationship, we are talking about how a table or how a record relates to another record. For instance, we'll be still doing like I'll still do a demo on that account opening and show you. For instance, now if I want to, there can't be a transaction without an account holder. Hello? Like
Yes.
if there should be a transaction, then someone already owned an account somewhere with the entity, like let's say First Bank. For there to be a
Yeah,
transfer in
I
First
hear
Bank,
you.
yeah. Okay. For you to make transfer in First Bank, you already hold an account, right? So the relationship that exists
Yes.
because these people they have decided uh to keep their transactions in one table, keep their account details in one table, like where you have your first name, your last name, your sex, your date of birth, your address, your house number, your everything, your BVN. They have kept it on account details. So if I want to know everything about your account, I just pull up details about your account. If I want to know anything about your transaction, I pull up details about your transactions. So now relationship is just a way for us to associate transaction to the user who initiated it. In the case of the banking, so if there is a transfer, then the transfer is related to both the person it was transferred to and the person that made the transfer. So that relationship that exists between a table and another table is what makes us call all these SQL databases relational databases, because it helps us track transactions. For instance, if we suspect that you are performing some fraudulent activities, what we'll do is to run a query that will fetch all the transactions that have been carried out in your account. So all the transactions is a table on its own. We can record that you transferred today, you transferred tomorrow, someone transferred to you next tomorrow. This happened the other day. You used your card to buy online. So these are transactions. Some of them are kept in transactions table. But each transaction is related to the account holder that initiated it and also related to the person it was transferred to. So that is just relationship. So we say in some ways the rows in another table are said to have relationship between them. The manner in which relationship is established depends on the type of relationship. So we have three types of relationship: one-to-many relationship and many-to-many relationship. So the example we used the other day, let me drive it home with that example. I think it was a better example than the bank stuff. In a family, we have a father, we have the daughters, we have the sons, and we also have the father's wife, which is our mom, right? So now the relationship that exists, if we are going to maintain the Christian standard, the relationship that exists between a husband and a wife is 1-to-1. If we are following the Christian standard, right? That's to say, for a husband only has a wife, and a wife only has a husband. I don't know if that helps. So for a wife, there is only a husband, and for a husband, there's only one wife. It's not permitted in the Christian tradition for a man to have more than one wife. So that is called a one-to-one relationship. So for a husband, there must exist uniquely one wife. And if there be a wife, there exists a husband uniquely, not husbands. So in that kind of relationship, in any relationship where we see we only have, for one table, we can only have another related, for one record in a table, we can only have one single related record in the other table. We call that kind of relationship one-to-one relationship. But if you look at the relationship that exists between a father and his children, is it a one-to-one relationship, if I may ask?
Nope, it's not. That is a one-to-many.
Yes,
One to many.
yes.
Oh, yeah,
It's
someone
one
was
to
trying
one.
to. Okay.
It's not 1-to-1. How
No,
many?
it cannot be one-to-one because a father has many children. If there's only one
Yeah.
father and the worst children tells you that there are different children, therefore means that one is related to many because the children, and it's not one, it's not a child, children.
Yeah. So a father can have more than one. It's not a sin. If a father only has
Um,
one related, yeah. Okay, you still want to bring in a. So if a father has only one child or even zero, it's not a sin. It's possible we have a record in a table. In the case of one-to-many relationship, even in the case of one-to-one relationship, we can have a man that chooses not to marry. His name is also in the list of maybe we are just recording adult males. His name will still be there. So we can have zero or more. But in the case of one-to-one, we can have zero or one. We can't have more than one. A father can have more than one child, but a child, if you reverse that relationship, you see that a child is only attached to one father biologically. You cannot have more than more than one fathers. You can only have strictly one father. So I don't know the person that was trying to answer otherwise, if you see it this way now, or you still have challenges with it.
No
Do you
challenges at all. It's clear, sir.
no, someone was trying to think the other way. I'm just trying. I want
Ah,
to clear
okay,
the.
okay.
Mm. So I guess she has picked it. So that's the case of one-to-one relationship. We have one-to-many relationships. One-to-many relationship is just a father can have many children, and a mother can also have many children. Let's just do it that way. And let's say in a school, we want to have a list of all our parents or guardians. We can have a register for guardians. So if a guardian visits our school or registers the students, we can keep the guardian's details in one table. And for the students, of course, we cannot be calling if we are calling their roll calls, their parents' name shouldn't be appearing there. So now you find out that just a guardian can register up to three children in the school. And if those children graduate, all of them graduates from that school, his name might or may not, it may or may not still be in the school register. But in that case, his name is there and he's not having a registered student. So the relationship that still exists between guardians and the students they register could be one-to-many. Do we understand the concept of one-to-many?
No.
You don't understand?
Yes. Because I was
Okay.
like choosing a father to children as in one. So, and I'm choosing this basically because of that's how I understood it.
Okay. Now, how many children is a father allowed to have?
As millions as possible.
Okay, so you can have as many as possible. That means one father, look at it, one father can have many children. So one for father, many for children. So just call it one-to-many that way.
Okay.
One father can have many children. In school, one father or one guardian can register many students, right?
Mm.
In bank, one account can perform many transactions. I don't know if you're seeing it now. How in bank, with your account, you can perform many transactions.
Okay, that's true. Yeah.
Okay, you get it now.
Yes.
So what if we want to look into the relationship that exists between a husband and a wife in a core Christian tradition? Can a wife have many husbands?
Ah. No.
So one wife can only have one husband, and one husband can only have one wife, right?
In Christianity, yes.
In Christianity. So if we have a school, or let's say uh, where you're working, they are doing this thing for you. They said you can only, those they are this thing, the HMG, you can only bring one person that will benefit from your this thing, like all those health services for their workers. They said you can only you can bring one child. So that's kind of relationship. You see, you can only bring one child. The company doesn't permit you. If you have 20 children, it's your business. You don't bring 20 of you can only enroll one child for those benefits. Or let's say you want to give out some things from your workplace or an association you belong, and we are mandated to bring one person. You see, they'll have a record for their members. They will also have a record for the people, the beneficiaries.
Beneficiary.
They are bringing. You see, in that kind of arrangements, I'm just giving you some scenarios where we can have one-to-one relationship. If you decide not to bring anybody, it's fine, but you cannot bring more than one person. When we now check the record and we are seeing that Mr. Michael brought two children, you have defied, you have what's the right word? I'm trying not to be safe. So you have violated the constraints, you have violated that rule. You are not obeying that rule of one-to-one. I don't know if we have been able to get it. Why we are taking time to explain this kind of relationships that exist is that it will help us query the database we are going to create.
I think the relationship example supposed to be even with father and children. Their relationship is still one because he gave birth to them and the love is still there between father and mother. Why the relationship of one to many supposed to be a father to other children that came from other people, which is not even his own biological son or children. I think that should be father to many so that we can really understand much better. Because the analogy is, I think it's supposed to be like that.
Now
But
stop
for
thinking of
me,
it
I've
like
gotten it already. I've gotten the
yeah.
illustration. But for me, that's
Yeah.
how it's supposed to be for me. That's why I explain it to myself like that now.
Okay, that's not how it exists in databases. We are in databases, we are thinking of how many. Think of numbers. We are not thinking of emotions or
Intimidate.
relationship,
Okay.
intimate or whatever. We are thinking of how many numbers, how
Okay.
many records can be related. Yeah.
Okay.
Think of it as numbers. Yeah.
That
Don't
would
just
be database analogy.
yeah, is that we are dealing with databases now. We are not dealing with family relationship.
Okay.
Yeah.
Understood. Thank you.
Yeah. So now we have what we call empty relationship diagrams. You can see them in short, ERDs. So what they just do is all these relationships, we are saying this is related to this, this is related to this. There's no way for you to know that this is the relationship that exists until you are handed the. Let me show you an example. The database we have chosen to work with
Okay.
has plenty, it has so many tables. So if you call me to come and analyze data in this database, I just put it, I've worked with it before, but I've forgotten the structures. So if you call me to come and analyze data in this database, I will struggle with knowing that the way password is related to persons. I will also struggle with knowing the way culture is related to maybe contact type. The only way for me to know that, the only way I could be sure is when I'm handed over the entity relationship diagram, which is prepared by whoever designed the database. So in this case, let me just see if I can search. Let me say adventure works because I should have it. Adventure works database. ERD. So with this, okay, this is their own. Like for the adventure works, we should also have the empty relationship diagram, which describes the kind of relationship that exists between them. It could get messy, but you have to, for you to efficiently traverse a database, you have to take your time to study them all. That's the first thing you're going to ask if you get to a database where you'll be performing analysis or you'll be working with for sometimes. Just ask them for their empty relationship diagram. They will give you. And for the database we are working with, if you even query very well, if you ask for the twin state, because I'm seeing so many of them, they will give you a relationship, a table that tells you the relationship that exists between the tables. Like in this case, we have stores, we have discounts. You see, in the other entry relationship diagram I used to demonstrate the other day, you see, we are having infinity at the many side and this at the one side. So looking at this, what it's telling us is publishers is related to titles in a one-to-many fashion. One-to-many in the sense that if you're looking at here, you're seeing 1, 2, 3. If you watch this drawing here, I don't know if you see what I'm doing. So this is telling us that this is one-to-many. This is the one side of the relationship. This is the many sides of the side of the relationship. For this, we have one-to-one relationship. There are some tables that are not related at all. Like this table is not related to this table. If you must trace the relationship between this table and this table, you're going to write a query that will verify that it will just follow this relationship tree. Sometimes you might need to write some table. Okay, the relationship is even broken. So I think the relationship you have to trace from here, enter this from this, you move to this. This is related to this. From this, you get to this. There are some queries when we start writing sub queries and joins, which are like stuff that very soon we'll get into them. If we start writing queries that involves joining and writing sub queries, you have to understand the relationship that exists between. Otherwise, when you query, you will not get to this because you won't know how to trace it. So this empty relationship diagram is just a compass. It doesn't completely describe the database we are looking at. I don't think this is it, but I just want to use it to illustrate for you. So as you're looking at it, you also see that we have FK. Some of them will show you the constant that exists. This is the foreign key. The other side, we have the primary key and the rest of them. So tracing these lines tells you how they are related. For me to trace the relationship that exists between this one and this one, there's an auxiliary, there's an intermediate table. So I have to move to this table. My query or my code, we have to touch this table in order to get this table. That's not meant to confuse you anyway.
Excuse me, sir. From the image, I saw broken lines and solid lines. Is there a difference between those broken lines and the solid lines?
The stuff is, if you get to an empty relationship diagram, you have to, sometimes they used to have what they call keys that just illustrates their drawing and what they need. You understand? So for this, I just put it up. So if I must answer that question, it means I have to take my time to look at it. Like if you look at this one now, okay, this, if you look at this now, you see there's no broken lines here.
Yeah.
So you just have to take your time to understand whoever designed the database and the conventions it's using.
Okay,
In
I
this
get
case, you don't have it. Yeah. In
get
this
the
case,
point.
they are even doing stuff like people who are doing product design. So that informs how you're writing your query, because without that, you just be limited to writing query that exists in one table, and that's not what most people will hire you to do. People will hire you to, when you're performing your analysis, you're just trying to check how this table, how this collection, what happens if there's an activity in this other collection. That's the analysis. When we start doing regression, correlation, is there any observable difference or trends when something like this is happening in this collection? Does it affect this other collection in the other way? So that way you need to start joining tables, querying
Uh,
across tables.
okay, I have a question. Yeah, if I want
Yeah.
to work as a data analyst regarding a project, so what are the basic tools that they will hand over to me?
Okay. The basic tools they will hand over to you is the data. They have
Okay,
to just give you the data. Yes.
okay. They will also give me this relationship table.
Yeah, for you to traverse any database, you have to understand, work with the entity relationship diagram.
Okay.
Anything, yeah. Because database, the way I'm designing, like the other day when we were making our design decisions, we were making our design decisions how on based on how it suits us. The next person coming to our database will not just come and know that these are the decisions we made. So in order for us to communicate the decision we made that we wanted to relate this to this, there are some, like if it occurs very often that people who are interested in this table are always interested in the other table, it makes sense to not make the relationship between them too far, like we demonstrated. I want to go back to the, though I'm not, the database I'm pulling up, I don't really understand them that much. They are just there. So if, for instance, this should, let me just,
Mike,
yeah,
sorry to cut you off. This is I just want to give you a comment. Like
okay,
I think we probably are making it so much distracting because you're showing us a lot of pictures, and I think a lot of people have not really gotten the basics yet.
okay,
Is there no way we
yeah,
can just start from simple single maybe just two tables, show us the diagram before we, because as we are seeing these pictures we're all getting confused. Like Clovis just asked now, like what is the solid line, what is the dashed line, just because they are seeing these things. That's why all this
okay,
question is coming up. If you can just make it
okay.
very
So,
very
so
simple basic example, that way they can grow their knowledge on these
yeah,
things. You understand?
yeah. So
All right.
basically, yeah. Okay, basically, entity relationship diagram is just a diagram. I don't have any like a very simple one to show. Okay, I have one.
If you go to
Relationship
the
diagram.
if you go to the IDE, if you go back to SQL Management Studio, you can try to
Yeah.
use the designer and just add a couple of tables that has a
Okay.
relationship. Just two tables that has a relationship, and then show them
We
how
were
it looks
trying to
like.
do that. We were trying to do that the other day, and I think it was now sounding a bit technical for them. So that's just it. Let's over time you get to know what's like. Just know that entity relationship diagram is your compass, your
Sorry, I believe
database
that if we
where you're.
start working with tables, we'll be able to get all these things. So if we are just looking for
Yeah.
examples, now it will waste lots of our time. So let's just maybe by the time we start working on relationship,
Okay.
we have our
Yeah.
understanding of it.
Yeah, Mike, can you go back to the IDE, please?
Okay.
And just create one new query. Just click on the new query button. The new query, yeah. And then right click on the query window.
Okay.
Click on design query. Design query in the editor. Go down, down, down.
Okay. Okay.
Yeah. And then here, just add two tables like employee and probably departments, and then show just single relationship between those two. A very, very
All right.
basic table. That way they will get conversant with the IDE, plus they will understand what the table is.
Yeah. All right. So let's do exactly what is being said. The other day we tried doing something like this, and I think for the fact that so many of them were still asking questions, like there were some questions that many of them were still asking that brought about this.
Yeah.
So
I'm
it's
not
not
saying you
like
should create
we,
a table. I'm
yeah.
not saying you should create a table. Just use the existing ones, like the adventure works you have just now. Go to
Let me
adventure
not use
works.
let me not use the adventure works. It's kind of complicated.
Okay,
Let's
look
use
for
this.
a database that is very, yeah.
Yeah.
And then just create a
So
new
here
query.
we have just how many tables? 5 tables. To create a table, we just do this. I showed you how to create a table the other day.
Okay, no, I'm
So we
not saying
just
you
do
should create a
this.
table. Mike, you're not understanding what
Query.
I'm
There's
saying.
not gotten to the point of that querying.
No, not the query. I just want you to show them how a relationship looks like on designer. You understand what I mean?
That is the design I pulled up now.
So just no, go back to the query window that I asked you to do. Click on the table, create a new query, and then choose the database. The database should be your database.
Okay.
It's selected. No, you're in master. Select change to your database, and then right click on the designer, and
Okay.
then add those two tables, any table you want, any table that has a relationship, like in ingredients or recipe, something that has two relationships. Just click on them, click on one of them, click on one of the
Okay.
tables, click on add, click on another one that is related,
Okay. Okay.
and then
Okay.
just two, and then close it.
Okay.
You
I'm
understand?
not
Yeah,
so
yeah,
used to
that's it.
I'm not so used to doing things graphically this way. So currently, yeah, thank you so much for that. I'm not so used to doing this. So basically, what we are seeing here is that we have a primary key here. This is actually the ingredients ID. Primary key. If you look closely, you'll see where we have a key. And this primary key reflects here. I don't know if you can see what's happening. This primary key reflects here in the recipe ingredients. We still have this ingredient ID that we have here, and we are seeing that the relationship that exists between them is one to many. I don't know if you're seeing this infinity sign here, telling us there's a one to many. That means one ingredient can have how many, like, can have many recipes. Do we get that? Thank you so much for this talk.
Yeah. And
Yeah.
again, here, ingredients on the recipe will be the foreign key.
Yeah.
Why is a primary ingredient ID? Why is a primary key on the ingredients?
Yeah, it's a primary key in ingredients and it's a foreign key here.
Foreign key,
So thank you so much for that. So that is a very simple way for us to get this thing. What we just did, like what he said, is if we open a new query, you know how to create a new query. You right click and go to design. I've not seen this before. You go to design. That was design editor.
Hold on
So
now.
on the design editor, you're going to right inside the table where you're going to select a table, click add, select another table, click add. It will bring out, okay, it's like these ones, they are not related. Maybe if we add more tables, we are going to see another one that connects them. Let's say this is recipe ingredients. We had something like that before. Sorry. So most times the editor, this environment will find that relationship that exists between them and show that to us. Let's add more, sorry. Maybe. So I don't know. Thank you so much for that. Whoever brought up that idea.
Yeah, don't always forget to highlight the name of the database before going to
No,
design.
we are already there. We are already there.
Yeah, no, just a quick notice for our fellow members.
Okay. So I don't know if we get that.
Okay, just click on the shift and then highlight all of them.
Okay.
While clicking on shift, it will show, yeah,
Yeah.
and then add it all.
Okay. So adding it all, thank you so much. You see why?
You're welcome.
Yeah. So this is beautiful. With this now, we can easily see the relationship that exists without even going to the entity relationship diagram that I've been stressing us about. We can easily see that ingredients is related to recipe ingredients, and whenever we have ingredient ID here, this is a foreign key here, and we have one to many here. The relationship that exists between ingredient class and the ingredients is also one to many. Ingredient class ID is related to this other ingredient class ID in ingredients. So that means ingredient class can have many ingredients. Then the one that exists between this one, see this line? I don't know if I can. Okay. So drawing it out makes it clearer to you, because when it was here, you couldn't see. Makes it clearer to you that there's a relationship between this and this. Since there's no relationship between this and this, if you want to trace the relationship that exists between them, you have to write a query that touches this before moving to this. So thank you so much for that. I love this. I love this. Did we get that? Do we have questions?
No questions for now. Perfectly understood.
No, not
Yeah.
perfectly understood though. Confused.
Okay.
I'm totally confused.
Nothing me with him.
Hello,
All
good
right.
evening.
Look at it.
Clover should
Yeah.
always sit down for us now. We are beginners. We are learning. Mr. Clover, please exercise patience for us to learn. Oh,
Okay. Yeah, that
So,
means whenever we ask for questions, now you guys should ask.
Okay, Mike. So
Oh,
just
yeah.
drag the designer window to the top left and then make it bigger so you can actually have more space. You can make you can make designer screen bigger. Drag it, expand it.
I'm not seeing
No,
that.
just go to the left, any of the corners of the window and drag it.
Yeah.
Make it
It's not
wider.
doing
Just
exactly.
make it wider. Just drag the left side.
Okay. Yeah.
And then arrange it in a way that they would understand, they would see well.
I don't even think this relationship is why they are absent. So now look at it. Let's move this. See, the person that says you don't understand, where exactly do you not understand? So that's
because the arrow of the key, the way it was pointed to maybe as many as one. So
okay.
that's where we are confused.
With this now,
I think
look at
what we should
wherever.
do, just describe them, the relationship between this and this, one
Yeah.
after the other.
Okay.
Just do two tables. I think it's fine. Recipe and recipe classes. So
Okay.
avoid
The
more
relationship that
confusion.
exists, yeah. The relationship that exists between this table and this table is what? One to many. How do you know? Wherever you see this key, I don't know if you can see this key icon. There's a tiny key
Yeah,
here.
showing yellow.
Yeah, it tells us that this is a primary key here and it's foreign here. So when we have it as primary key here and we have this infinity here, it means that the relationship that exists between this and this is one to many.
Mhm.
Did we get
Okay.
that?
Yes.
So if you got it, what's the relationship that exists between this one and this one?
Which one?
These two tables,
The
recipe,
recipe ingredient
yeah.
and
Recipe.
what? And
Recipe,
what?
ingredients, and recipe.
You can't see the
Yeah.
recipe. Our, what are you calling it?
This is
Our
recipe.
Zoom,
This is
this thing is
recipe.
covering it. Okay, recipe ID.
Yeah. This table, this one I'm moving on, and this one.
Yeah, I think it's still a bit scattered. So right click on the ingredients and remove it. Ingredients table, just to give more space. Not this one, not the other one, or ingredients at the top. Right click and remove,
Okay.
and then
All right.
remove the other one so that I can arrange this properly.
Yeah. All right. So is this better now? For those of us asking questions. Let me even remove this. We now have 3 tables left. What's the relationship that exists between this table and this table?
Can we drag the little bit of the recipe of this side to this side? Because the Zoom view is covering it. Yes,
Where
yes.
is it?
It's okay.
Okay, okay, it's because of the way you set your Zoom. You can just expand everything. So can you see the relationship that exists between this and this? The last person that spoke.
Yes.
What's the relationship between this and
One
this?
to many.
Which one is the one side? Which one is the many
Recipe
side?
ID and recipe ID, recipe ID and recipe ingredients.
Ingredients. This one is recipe. So which of them between these two, which of them is the primary key and which of them is the secondary key? Where do we have the one to many?
Where we have to one to many is recipe ID, recipe sequence number. Then the other side, recipe ID.
No, hold on. Look at it. This between this table and this table, we said because we have a key here and we have this infinity sign, that it means we have a one in this side to many relationship. Like this one is the one side of the relationship. This one is the many side of the relationship. So I'm
Okay,
now
Mike.
asking, did you
Yeah.
get?
Yeah, sorry, Mike, if I may. So, Mambila, let me try
Ma'am,
to
sir.
explain. Let me try to explain this way. Remember the
Okay.
last time we talked about ogbono soup, right? So look at the recipe table as the place you store different kinds of soup. So in recipe table, we might have ogbono soup, and then recipe ingredients will be the ingredients we use for the soup. So which means ogbono soup will have multiple ingredients.
Oh.
So that will be a recipe. We have one record to many ingredients. So ogbono soup will have many ingredients that makes ogbono soup. So that's the relationship is one to many. On the right side is one.
Yeah.
On the left side will be many. Now, if you look at the recipe ingredient, that means that will be a many to one, meaning many ingredients constitute the ogbono soup. Now, looking at the recipe classes, let's think about that as Niger food. Would that be correct, Mike? Let's say
Maybe,
Niger
yeah.
soup. Okay, that would be a class of a kind of recipe. Maybe we'll call it Igbo soup. So the class of that soup might be an Igbo soup, and then the actual recipe is ogbono soup. I don't know if that is a bit clearer.
Okay. Out of Igbo soup, we have ogbono, which is one.
Yeah,
Yes,
there's one thing I
correct.
also want you guys to know. Just this stuff now we are doing, you need to personally you need to also, like, there's your own side of this stuff. You need to spend some time trying to know this on your own. We might not be able, because the problem, if we abstract this away too much, like if we try to say them in a lot of abstract sense, bringing it back home will still be a problem. So on your own, there's an effort for you to make. So try, whenever you are free, just try going over some of them, because it's more like you guys are the one holding us from moving forward.
Okay, now let me. Yeah, this is also what I'm seeing. look at the heading of the table as what you are using as a reference point, not the items.
Yeah.
Now, when you look
Yeah.
at the recipe class, the relationship it has with the recipes, it's 1:many.
Because of
Because
it's
look,
one because of this sign we
yeah,
are seeing
because
here,
this
this
arrow
key we are
here,
seeing
yes,
here.
yeah.
Because we are seeing key here in this side of the relationship, and we are seeing infinity, we are seeing Tinubu sign in this
That's
side of the
many, yeah,
relationship.
yeah.
Yeah, so this is many. So
Then
based on that,
on the recipe and the recipe ingredients, the relationship between the recipe and the recipe
One to
ingredient
many now.
is 1:many.
Yeah.
Yeah, then when you flip it, recipe ingredient versus recipe, it will be many to 1.
yeah. So let this just be a tip. This should always tip you whenever you see this key and you see this, it will be a tip. So if you have this infinity and infinity here, that means it's a many-to-many relationship. So try on your own. Again, thank God we already have this. If we can move a bit faster today, I will help you show you how to get these databases into your system, because this one is a bit simpler. And doing this will stay. You get it. So on your own, you can just study it. You saw how he described it. Just come to this, create a new query, right click, come down to design editor, add the tables you want under the database. You can add 2 tables and say, okay, so already the relationship appears. You see the relationship that exists between them. And it's even a better way to do all of those. So I hope we are good with that now. We are good, right?
Mr. Mike,
We are good.
if I may suggest, this one that you are saying that we should close and go to the next step. You know, it is much better for us to be conversant with what you are teaching us and be able to interpret it for you to be happy than for us following you as a novice and not even mentioning that we don't understood. You know, it will not be good. So it is better for us to know it, and you will also be happy when you give us work to do and we got everything right. You know, that would be much better.
Yeah. I'm not disputing that part. What I was just trying to say, I'm not going to run. I'm not going to rush it. What
You
I'm
know
just
what you
trying
are
to
going to
suggest
do
is
for
that
us?
on
Whenever
our
you bring
own,
out some things now and you explain to us, you know, we have 2 parts on this our lesson now. We have some people that are already maybe little
very
bit
good.
conversant with this database.
Yeah.
While we also have
Yeah.
some people that are really novice, you understand? So when you are
Yeah.
teaching us, try to ask questions from 2 of us that we have not even seen it before, and 2 people that have already have an idea. That's when you will know that we are following you.
Yeah. Okay. So do we have more questions now?
No, for me, I'm okay. I'm good to go. I understand the way it was explained now.
How about others?
I think there's another lady in the
We are following. We are
group.
following.
I think there's someone else that was confused initially. Let's ask to be sure that she's following. Sister Dossie, I guess.
See, can we just go over the new design process again?
Sure. Let's go through it one more time. Please, Mike, can you please do that again?
So what we do, like initially, the database wants to monitor the design. We have to be inside the database. This is how you move from one database to the other. So clicking this, once you use that recipe ingredients, so recipe examples, we are already in the database. To do what we did, you come to this, assuming we don't have this query stuff on. Let's say we have our workspace looking this way. I want to move into the query mode by clicking on new query. From here, we now right click. That was what I did to get this. Once you right click, this pops up. You come down to this one that says design query in editor and click OK. So clicking OK to bring all the tables in that database. We now select any, add, it comes up there. We select another. Once we hit add, it comes up. We hit add, it comes up. Once as it's coming up, it's also coming up with a line that wants to show us the relationship. Let me just leave this one. I'll still add more. It's coming up with a line that is trying to establish the relationship that exists between them. Maybe I should also draw this out again. So are we clear on how to get to this point? From this point now, we're able to see that this ingredient is related to this ingredient class in a one. How do we know it's one? Because of this key. Once we see this key and we see infinity in this side, we know it's 1 to 1. I mean 1 to many, sorry. So this connecting line
Very
tells
clear
us
now.
what is clear now. How about others?
Yes, it's clear now.
It's
Yeah,
clear.
it's clear.
What does
So
the straight line say? Sorry, what does the straight line? Because you just changed it from 1 to many. This other straight line now, what does that say?
that's what it's telling us. Like there's no line between this and this. So we can't say for sure if there's a relationship between this and this, there should be an auxiliary or an intermediate table that is connecting them. So once we see a line from this to this, it tells us there's a relationship. That's what is telling us there's a relationship. The line itself is telling us that this is related to this. There's a line, there's a connection between this and this.
Yes.
I don't know if that answers your question, sir.
Yes, I just wanted you to say that. Thank you.
Okay. Okay. Thank you. So let's try and move on. So I can now move on, right?
Yes.
Okay.
Yes, thank you, sir.
So yeah, that's just the other day we said SQL is just the language we use to interact with our databases. That's what it is. Let's not go into and see. So SQL is just the language we speak to our database and it responds to us. We demonstrated how to create a table the other day. Let's do that again because it will pay us to use that to explain data types. I'm going to delete this. Or let me just paste a new. So to delete the database, you just right click it and hit delete. Then okay, that goes. Now, if I want to create a database, a fresh database, I just come to this database, right click it and say new. It prompts us to give database name. So in this case, we can just say lesson 02. So this is lesson 2, and we are calling the database lesson 02. You can call it whatever you want to call it, and say okay. Once you say okay, you see a database is already created with the name lesson 02. Do I need to redo it?
Yes, please, please, please. I really like this part. Please, can you just redo it please again? Thank you.
Yes, sir,
On
please.
your
I'm not
databases,
seeing your screen, please. I'm not seeing your screen, please.
how about others?
We are seeing it.
Yeah, I'm seeing the screen.
You can see your screen.
Okay, from this place, to get to this point, we click on databases and it expands, right? So just come to your database. Let me expand it so that we see it. So I deleted it. Right click your database, say new database. It
Okay.
will bring up this panel that says database name. Let's leave this, just give it the name. So in this case, we want to name it lesson 01 or lesson
Okay.
02.
Lesson
So click
0.
click OK. So once you click OK, a database is created. Now, remember, inside databases, we said databases are structured in tables, columns, and rows. So inside the databases, you have this option that says, this file that says tables. Expanding it shows we don't have any table yet. So to create a table, we do exactly the same thing we did to create a database. We did this at this database level. Now we are inside the database. To create a table, we just do new again. In this case, we don't have new database. We now have new table.
Okay,
Should I
new.
also go over table? Yeah. Should I also do it again?
This part now, the one after you created the lesson 01, you said you created a new table, right? Like a new database again.
Yeah.
Okay.
This is a database. Inside the database, we are going to have tables.
Okay.
Okay, so just to add to what you just said, so a database, you can see it as a bucket, right? You have a container that you want to store things, but then inside that bucket, you want to have small plastic containers as well. That will
All
be your
right.
table. So you have a huge bucket having some smaller containers inside. So he has just created the buckets. Now he's trying to create the tables where you store the actual items.
Okay.
Okay.
So to create the tables, you just click on table, still do right click, new, then table. So again, just look at it. Everything is a step. We'll move from database to tables. Someone's mic is noisy. Yeah, someone's mic is noisy. Please just mute. Okay. So from databases, we get to tables, and from tables, we get to what? Columns. So now we've created our database. Inside our database, we want to create a table, and inside that table, we are supposed to have columns. Columns are just those our distance. So here, I don't know what we are going to call this database. Let's just say customers for the name of the database. But a customer will have what? Let's just say ID. This ID is going to serve us as our primary key, which is our unique identifier. Someone's mic is noisy. So let's have, we said we always have our primary key, which is our unique ID. So let's call the first column our ID, or we can call it SN as we like. But let's just say ID standard. We have a column called ID, and inside that ID, what do we want to put there? We want to number them in 1, 2, 3, 4, 5, 6. If you drop down this list and scroll up, you see a lot of data type, big int, binary, bits, characters, date time, and so many things. So depending on the kind of data you want to store in this table, in this column, you choose the data type. So in this case, what are we going to choose based on what we discussed the other day? I want to put numbers from 1, 2, 3, 4, 5, 6.
Integers.
Yeah, we are going to use integers. An integer is just a whole number. That's the definition both from primary school. So we are going to use integers, and we don't want to allow it to be null. We discussed, because we want this to be the unique ID to this to each of the records, we can't allow it to be empty. We will not allow null. So not allowing null means we don't want it to be empty. We'll move over to the next thing. I just want to record customers. So what else can a customer have?
Sorry, Mr. Mike.
Yeah.
The last time you told us that using integers data type applies when we want to perform arithmetic operation, but for ID, you don't do such things. So why are we not using the env and the stuff we used?
All right, let's
Remember
not
the
use that,
discussion
because look at it. There's a calculation we are performing on it, which is that
on ID.
calculation. Yeah, there's a we want to auto generate it. The next one should just add 1. So implicitly, it's adding 1. That addition is an operation. If we do it as character and we add 1, it's going to give us 11. So it's an integer we are indirectly performing. To get to the next one, we add 1. To get to the subsequent one, we add 1. We are adding 1.
Okay.
Yeah. So the next, for a customer, what can a customer have? A customer is going to have a first name, right? So how is this first name going to be recorded? Is it going to be recorded as a collection of characters, as an integer, as a decimal number? Big integers This big int is just big integers. Let me go over all this, some of them. I don't know all of them, like I told you. You don't even necessarily need to know what everyone does. So big integers is when we want to record, like for account numbers which run into tens, we require big integers. I don't know the limits between like the range of values, but if you know the number you want to be storing is going to be running in millions, billions, it does good for you to choose them as big integers. We have binary. I can't really binary and bit. I think bit is just Boolean for true false. I can't really remember what this binary is, but maybe you guys can research on that, and I will also do that. So we have characters. We have characters. We have bit. Bit is for yes or no, male or female, on and off. Whenever you have to choose yes or no, like whenever there's an option for you to choose, and those options are just between yes and no, on and off, you use bits. So for characters talks about like my name. My name is a string of characters. So when you string characters together, you form a name. In this case, we use characters, but the difference between, for characters, if you define it as 10, you can change this variable to 20. This is just you can change it to 20. That means it can take up to 20 characters. So if you use characters 20, it means reserve space enough for 20 characters for me. So it's going to reserve space for 20 bytes. Whereas the difference, whereas for mvarchar or varchar, is it will reserve space enough to, it can accommodate up to 20, but if you give it 10, it will only reserve space for 10. If you give it 20, it will only reserve space for 20. It will only reserve space for 20. So
Wait,
we have
from this,
numeric.
excuse me, from this explanation you gave, that means the N voucher and the char are doing the same thing.
Yeah, they are doing the same thing, but one is more dynamic. The mvarchar is a bit dynamic.
Okay,
Mvarchar just
what makes it dynamic? What makes it more dynamic?
What makes it dynamic? Characters. If you have character 20, that's char 20. If you give it 10 characters, it will still take up space enough for 20 characters. If you give it 2 characters, it will still take up space enough for 20 characters. Whereas the mvarchar adjusts itself. If you do mvarchar or varchar, if you do mvarchar and you give it 20, if you say mvarchar 20, it cannot take more than 20. But if you give it 10, it will adjust the space allotted for that column to 10. Okay. If you give it 5, it will adjust by itself. So for the distance, I would like us to just save it as
then char is better. It's better to be using char all the time since it's flexible.
No, what is flexible is varchar, variable character.
Okay.
We have varchar, we have mvarchar, we have that char. When you have n accounts for international numbers. International characters, like if you want to start bringing in Chinese sign and all those things, it accounts for it. But if you just have varchar, it's only English, Arabic alphabets. So let's just try and speed this up a bit. So just know whenever you want to collect names, it's going to be a string or it's going to be a collection of this thing. What's it called? So here we are going to use mvarchar. We can assign 50. And of course, the person must have a first name. We don't want him to not have first name. For the last name, we can have last name. And for last names, we can also have, last name is also going to be mvarchar. And we don't want the last name to be optional. For maybe other names, we can have other name. How are we going to store other names? Sorry. How are we going to store? Other name is also going to be mvarchar, right? And we can leave it as none. Why do we leave it as none?
Because there are some persons that will not have other name. They just have first and last name.
Yeah, so for the ladies that said I should always ask them, do you understand what we are doing here?
Yes, sir. Yes, sir.
Yes.
Yes.
You're following what we are doing?
Yes, sir.
So for the phone numbers, the customer might have phone numbers so we can contact them. Of course, we are also going to save phone number as words. We can use we can just use char and save phone number for Nigerian for Nigerians, we used to have 11 numbers, right? So depending on what we want to do, we can decide to leave them not to have phone number, not to have phone numbers, or we can decide that they must have phone numbers. Then for their email is going to come as what? How do we store emails? Email is going to come as M version, and that's the data type. What is the kind of data I want to store there? That's just what I'm asking. So how do we store emails? So we can create this table. To create a table, once you're done entering what you want to enter, all the stuff you want to enter, you just try closing it. It will ask you to save. You say yes. Please always ask your questions while we are doing this so that we don't keep going round. We can call this customers. Right? We understood what we did there, right?
Okay, sir, please, what did you click to save this one now?
I just clicked the X button to close it and it's saved. So if we
Okay.
come into this, coming into this database we created, if to check if we have tables, I can just disconnect and reconnect so it refreshes. So that way, we now have this. So under our tables, we should be able to see that customers table. Now, what we did, a table doesn't mean we already have entries in it. It's just like when you're trying to collect this thing, you draw lines, you draw the first line for serial numbers, first name, second. So doing this table, creating a table is just drawing that line, nothing is there, right? To put things there, we'll come and say, someone's mic is on. To put things there, we'll still come and right click on that table and say, edit top 200 rows. To edit top 200 rows, we can decide to leave this because we want it to auto-generate. We can add it, we can decide to leave it. Some first name, let's use my name, we say Michael. Last name, my last name is Oko. I think we left other names as no. We can enter my phone number as 080-321-33-774. Then email, I think we also allowed email, but let me. What's this saying? ID does not allow us.
I don't think
Okay,
you
it's
set
supposed
the
to.
ID
Sorry,
as auto
Yeah,
increment yet.
I didn't set it. So now to set this as auto increments, we are already. No, we have to go to edit this thing again. We have to go to the design.
Properties.
Okay. So we'll come back to the design. Sorry, I didn't. To make this an ID table, you click on this ID, and first we set it as primary key because we want it to be our primary key, right? So on your ID, you right click, set to primary key. So once you set it to primary key, you see this key icon here. This is also still highlighted. I want to make it as an ID table. That means I want it to auto increment. What we do is we'll come down to this place. This is like the properties. It's telling you more things about this thing. You scroll down to where you see ID. So we have ID specifications. Click on this ID specifications and change this to yes. You change this to yes. So once we change it to yes, automatically it tells us about the seed. The seed is where do we start? Do we want to start from 1? How do we increment? Increment by 1. So if I change this to maybe, let's say I set this to 3, that means the first table is going to start from 3 and increment by 1, which is what that ID, whatever we did then is. So we are going to leave it as 1 1, and Yes. Spelling change is not permitted. You may require the drop to our language. Hold on. Let me recreate the table. I'm not so used to doing things this way. We'll start writing our queries. You see how to always do this. Sorry, I'll quickly go over doing that again. So from here, we right click again. We are going to say what new, sorry, not that. We'll come to table and say new table. Sorry, I just want to, so here we have ID, right? We agree that our ID should be integer, right? We are going to have them as integers. Not no. We have first name, Basha 50. Not no. Last name. Not no.
Sir,
Yeah,
please,
check the first name. The first, then the N should be capital letter. I think when we are using a format, we should use it uniformly.
Okay, so we have this. Other names, we can allow it to be null. Then we have, what did we, okay, we have phone. Phone should be Ensha. We have 11 here. A decision made by whoever is designing. So here we have image should be mVasha, right? But let's set it as 100. Some image can be done. We can allow it to be null. Let's not allow this and click close. Okay, before clicking close, let's set this as primary key.
You skip the phone number.
Okay, I skip the phone number. So to insert, you just come to this table, highlight it, and insert column. Okay, not where I wanted it. But we can have it there. Let's leave it there. So we can just say phone so we don't waste time. Our phone number is going to be, but I thought I did that. So we have 11. We don't want it to be null. Then for other name should be mVasha 50. So I believe this is good now, right?
You can also drag it.
Okay.
Drag the field.
I'm not sure doing that. Okay. So on that note, we can drag this down and we have it rearranged. So this way, if you try closing this, we now save the table. No. Let's not do that yet. Oh,
So are you not going to set the primary key again?
that's what I just forgot.
The primary key name.
Yeah.
I
See, just remind me so I don't. So here we are going to have ID.
Yeah,
Sorry, I'm
that's
taking your times.
great.
It's an int. Just it's an int, and then add the ID right there.
Okay.
Make it an a primary key right away.
Okay. Yeah. So I don't hide things.
Lowercase.
So now,
yeah.
just so we set it just by clicking it, we can set it to primary key. And to make it ID, while it's still highlighted, you come to these properties, go down to identity specification, drop down this arrow, then under this, yes, I want it to start from 1 and increase by 1, right? We'll move on. So we don't want it to be null. Here we have a first name. First name is going to be what? mVasha 50. We don't want to allow null. Last name. Partial 50. We don't want to allow no. Then other name. Yeah, 10 partial 50. We can allow no. Yeah, phone. Phone is going to be, let's leave it as this. We can allow, let's not allow no. So email is going to be what? Version. Let's set this as was 100. We can allow email to be null. I think that's that. So we've set this as an ID key, and we've also done the auto increment. We just try to close and we save yes. It will ask us for the table name. So we said customers and say okay. Now to edit this, we can just come to this table.
Please, where did you click to save it? To save this table?
To create it. I didn't get you.
To save.
Okay, to save it, we just click after
Click
once we are
the
done editing.
X.
We just click the X, it will prompt us to do that. So here we have the table. To insert rows into the table, right click and say edit top 200 rows. It will bring up the editor. You see this way now, because we've sent the identities, brings it at 1 already. Okay, the one we are trying to. So here we can now say, let's say we want to add another one. We can just say Johnson. We might say Joseph as the last name. Then others, we leave it as north 08068934347. Then the email we allowed as no. You see, this time around, I allowed this as no and it went, and this is doing that auto increment. We can also say, oh yeah, we leave it and now have whose name? Someone should just give me a name. Deborah. You say? Deborah. So other names we can now say Jacinta or whatever. Whatever you put there, as long as it follows what we 07046009452. The email. My God. So this way we've simply done what? Created our table and loaded it with data. We'll do this. So to select all the entries we have in that table, we still do what? Highlight this. Let's click again and say select top 100 rows. Top 1000 rows. So if you do that, it's going to write a select statement for you and also output the results. These are the entries we gave. This is how to create table graphically. Do we have questions around that? Do we have any question around that? How we got to this point?
No.
How about others?
Please, can you repeat the last step again?
All right. We can say new create. Let's create another table, right? Let's leave this one we've already created and create another table. So coming to table, right click, say new, select table. Is straightforward. This thing is straightforward. So this other one, we can just say maybe we have customers. Let's record their orders. So for the orders, we can have order ID, right? Order ID. Then other ID is also going to be, let's leave it as what? Let's leave other ID as integers, right? Then we don't want to allow null, right? Then mm, other dates, we can have the dates it was ordered. Other date is going to come as what? Date time, right?
Yes.
So we have it as date time, and it cannot be null. So for this
The name
now,
of
let's say
item.
our name of items. Name of item will, because someone can order many items. I don't want us to go into that listing here. So we can just say order amounts. Let's have order amounts, right? Name is fine, but someone can order too many things at the same time. Order amounts. So how much is the person supposed to pay after the order? So how do we have order amounts? Is it going to be an integer or numeric or decimal or small money? We can say small money if we are not selling things that take so much money. So we can just say money or small money, or we can have it as numeric. So let's say money, because we are going to save money there. We don't want it to be null. Then for what else? I wanted to also have a distance. I want this order to be related to whoever is ordering it. So we can insert a column. Nope. Okay, we can insert a column. We say we can, and say customer ID, right? But in this case, I don't know how to officiate that relationship using this click and, because it's not how I've been doing it. So we are going to have customer ID. Let's say we don't establish a relationship because maybe, let me see. So customer ID is going to be, we want to pick that customer ID, that primary key from the other one and put it here, right? So for the customer ID, it was what? It was integers, right? Yeah, so we are still going to have int, and we don't want it to be null because we want to know who ordered. So with this, I think we should be fine, but let me try and see this order ID. Let me click and drag down this. So here we have order ID, we have customer ID. This order ID, I want us to make it primary key. So to make it primary key, we right click and set primary key. I also want it to auto increment. So we come down to this ID, making it ID specification. Click on this drop down arrow. Then say yes, right? We just say yes. And we can decide that the other ID, because we want it to look a bit fancy, we can say it should start from 1000. So we will have order 1000, order 1001. We can also decide to be counting from 0. But in this case, we can just, to add some randomness, we can say it should be counting in 2, right? So once we are done, we click this to close, and
Sir,
that will do it for
sir,
us.
wait.
Yeah.
The foreign key, is it customer ID or just ID? I'm not sure.
For
the foreign key, I think, is it customer ID or just ID?
Yeah, customer ID. No, we can name it
Is it?
anything and rename it.
You can name it and okay.
Yeah, and reference
Okay.
it. But calling
Okay.
it ID, yeah, let's have it as customer ID.
Okay.
I will click around and see if we'll be able to establish a relationship here. Okay, so from here, it also gives us the this and the clicking. We can still right click and say relationship. I think relationship should take us to, so we'll click on add. I think so. It should be a foreign key constraint. This one we are going to figure it together. So enforce foreign key, yes. And then there should be a way for us to give the reference key.
Okay, so there's an easier way. So if you go through the route of that designer, create a new
Yeah.
query.
Okay. After I'm done with this,
I
should I
just
save
click,
this?
just click on it. No need, it's fine. Just click it. Yeah,
Okay.
save this first, of course.
Okay. Yeah. Okay. So clicking this will save our table. And in this case, we want it to be order. right? The table name is others. So from query, let me just, so from new query, okay.
Yeah, designer. Go through the same route. Go to designer. Yeah, this one. And add those two tables.
Okay.
And then drag, once you're done, you drag the column. Oh, you added the
Okay.
same table, remove that,
Yeah, yeah. So it's not getting me that
Yeah,
one.
that's fine. Right click, add table.
Okay.
Okay.
So we have this. Yeah.
Now drag the column you want to be the foreign key. Just take that ID, drag it, and put it on the foreign key. From the customer table, yeah, drag it down to the customer ID. Just drag it on that column itself. It's fine, it's dragged. Don't worry, just move your mouse towards.
Okay.
Yeah, just
Okay.
move your mouse there inside that column. Then it should
Okay.
ask you a question. Now, right there.
All right.
So click on that line. So when you click
I
on the
should
line,
click.
yes, click on properties.
Okay.
Now here you can actually decide on which is which.
Okay.
How do you usually do it? Probably should go through your own
No,
route.
I do those things with code. I don't.
Oh, I see.
I barely, yeah. I don't do all this drag and drop.
Okay. So if
I either design
if it's
table,
fine,
I
you
either
can do
design
it on the
tables
code.
with,
If
yeah,
it's clear, you can do it on the code for them as well to understand. Just
yeah.
don't
Just
save
also
here.
understand this procedure and also the code one.
And the code is more efficient and most people don't do this. This one will both waste your time, and this is error prone because if I want you to have exactly the same code I have, I can just share my code, you run the code, and everything will be done for you. But if I have to, that means I have to come and supervise you to make sure both your namings and all of those. So code is reusable.
Yeah, you're right.
And I prefer to, yeah, I prefer to do it that way.
This is
This
just for
will,
learning purposes so that people can actually see
yeah,
what
just for
it's
learning.
doing.
Yeah.
Yeah.
Yeah. So with this now, I think if we succeeded, let it be an assignment. You guys will go try doing this, read up. Me, I'll also go do it. But that's not, in fact, over time, you can only, over time, over the, maybe let's say after some months, you start doing it the proper way, which is writing code. I don't do this. So, but we get the idea, like at least from here, we've been able to see that identity in action. Let's now, do we have questions? Sorry. Do we have questions?
So what can we call the relationship between the customers and the order now with this
I
arrow?
wanted to I wanted to establish a one-to-many relationship, but like I told you, I don't know how to. I'm not so used to this. I started getting used to it because of this lesson. I'm not so used to all this drag and drop. It's an easier way, but you don't want to. You prefer to learn how to write code than doing this. Maybe from here.
No, the code is another, that's of another day now.
I wanted us to introduce code today. I was even thinking after the last lesson, we'll just start writing codes. So if we succeeded, we would have established a one-to-many relationship between these two.
I think we'll try to figure it out.
Yeah, figure it
out there. While in
but
our next class, we can learn the code aspect, but we'll try to figure it out on our own.
yeah,
If we can get it, yeah.
yeah. So that's, I don't know. Because I had wanted us not to be running around this. It's just like we are repeating and we are on the same thing. I had wanted us to write code today. I thought we just introduced briefly, but what we did is repeating the other class. The code is the more efficient way. And if you go for interviews or whatever, they're not going to ask you to do this. They're not going to ask you to start clicking around. This is just for you to understand. Nobody is going to ask you to start designing tables with all this click, click, click. They are going to ask you to write your query directly.
Well, it's okay. I
But
think
it seems,
the revision we did was very, very good because right now everyone has
Please, can you
understood.
just allow him to just maybe little bit do what he wanted to explain to us? Then we close, please. Just let him
All right.
explain a little bit what he wanted to explain to us, please.
No, what I wanted to explain is just how to create this table. I would have been able to establish that relationship, but I don't know how my way around this too much clicking. So maybe we'll just write the same code we were writing the other day. Basically, we've created two tables here. Okay, let me disconnect and reconnect. It's already created, but if I refresh, let me see if it's refreshes.
Are you trying to do the relationship thing?
Yeah, I'll do it the
Okay, so
other way.
that's easy. Just right click on the go back to the table, right click on that on the table.
Okay, this.
No, just open the table, design.
Okay.
Yeah, right click click design, and
Okay.
then click on the column you want to use as foreign key. Go back to the other table. I think it's the other table, right?
Okay,
Yeah.
this other table.
Design, and then go to that customer ID. Now click on that and right click on that.
Okay.
And then click on relationships. So this is how you set the foreign key and the private. So now expand tables and columns. Just expand that. Tables and columns. There's a on your right side. No, leave that.
Yeah.
On your right side,
No,
on the
it's not.
table.
It's not. It's
No.
active. It's like.
No, not there, not there. Look at where you have descriptions, right? Properties. On this table, on this window.
From here?
No, the small
Yeah,
window
okay,
you
this
have
one.
opened. This one.
Okay.
Yeah, go
Yeah.
to tables and columns. Second row. Second row,
This.
tables and columns. Mike, tables and
Table and columns
columns.
under general.
Under general.
I can't see it.
Oh,
Under
okay. So
general,
do you
check
see general?
existing data.
Okay,
That thing
like
you just
here.
moved now. No, the one you just moved. You can see that window
Yeah.
you moved. There's a general there.
Yeah.
Yeah. You will see
Okay,
tables
yeah.
and columns. Expand tables and columns.
Okay.
Now you now
Yeah.
click on that the foreign key part you want, which is the other ID.
Okay.
Go down, next one.
Okay.
Second one, click and
Okay.
then on the right side you will see click the top one, the first one. The first one. Go to the
Yeah.
right side, the empty part. Just move your mouse to the right. Move your mouse
Okay.
towards the right. You will see a round. Click on it.
Okay.
Click on the next one down. You see, don't see anything. Okay,
Yeah.
sorry. Go click on the tables and column itself. Sorry, in the table and column you need to click on. Click on that,
Okay.
and then on the right
This.
side, this one.
Okay.
Yeah. Now here you will choose the primary table and then the foreign table that is referencing. So that means your
So
primary
in this
table
case,
is
my
customers, right? Then your
Yeah.
foreign table will be order, and then it's mapping
Other.
towards
Okay.
other ID.
Yeah. Okay. We say okay. I should go ahead with okay.
That's it.
Both
That's
sides.
it. Yes. Just giving you a warning. Oh, you didn't choose the other table, the primary table. The column.
primary?
Go down. You need to
Okay.
choose the column as well. No, it's fine. Just click customers and then go down. Choose.
Okay. So
Which
this
key is the
should be the
primary key?
primary.
Yeah. So basically,
And this
customers
should
ID
be okay.
references.
Okay.
You got it.
Okay. Yeah.
There you go.
So what you said now is actually the code. This references that's all we about doing. Okay. So with this now, I think after this we should just close. So with this now, let's test this stuff. It was from here. Okay. Add. Close. Okay, maybe I need to refresh this to enforce that.
Yeah, I think the time is fast spent. So probably by next time we would continue on that.
Yeah.
All right.
So I just wanted to check if that's this thing. Right click, design editor. That's fine. Okay, so it's not maybe so let's just go from this time. All this the essence of doing all this clicking around is just that if we jump into the code, it might look a bit challenging to us, but that's where we should be. That's what we should be doing. And from next class, we'll spend time trying to do this click around. And by His grace, clicking around has exposed us. We've been able to learn data types, and we saw the list, which is intuitive. Starting from next class, we are going to jump straight into creating these things with codes, because to write a query that will drive some stuff from your database, you're not going to start clicking. I don't know if people actually achieve it with all this clicking around, but it's going to be labor intensive, and you are not expected to be doing that. So the good thing you guys will do for me is, as you go, make sure you spend time learning what we've learned. Research online, use the materials we have, watch this video, ask your questions in the group, because we'll be building on that. The essence of all these things we did the other day and this other day is just to get you familiar with what we'll be doing. It's not like this is the real stuff. So that means from our next class, we'll start writing our small codes and also start querying some databases. Someone wanted to say something.
I'm just thinking maybe you should give us practice, like practice work to do on this for you to know what we are doing. Maybe we are following you.
Okay, you saw what I did. Look at this. You can screenshot just take a screenshot of what we have here. On your own, today is Thursday. On Saturday, we should have a class. So on your own, try creating this table. Read up on relationships. We'll be using them. Try creating this table. If you have time, create more tables. A customer places order, so there's another relationship. You can create a table that demonstrates that students and whoever registers the students in school. So guardian details. Always remember to put the ID, that's the primary keys, and make them primary keys, then make them identity in both tables. So this can be one of your assignments. Create it in your own, then create more, run into problems, ask questions, check online, post on the group chats. We'll be transforming all of these we learned into code. And moving on, we'll come back to this graphical editor again. So for others, I don't know. Do we have questions, or we should just close?
Yeah, I think we've today is fast spent, but most importantly, we have to look up to the Saturday class and always be there on time, so that we don't, because when we are late, we always ask questions and bring us back. So everyone should endeavor to be there on time. It will help us to move together and work as a team. So I think the day is fast spent already. We can end today's class.
Yeah. All right then. So if we are not getting further comments, it means we should close. Thank you guys. I expect you on that Saturday. Try and come, please. You help this class, you help us not keep looping over and over the same thing by studying. It's very important. Just make out small time and go over these stuffs. You might learn it today, but for you to finally master it, you need to do it on your own. You don't just, the one we learned today is just temporarily. By the time you spend 2 days, you must have forgotten it and you start asking these questions again. So look at what we did. If it means watching the video, it will be made available tomorrow. Watch them and come back on Friday. I mean Saturday. So we can start doing stuffs. Any moment from now, we'll start enjoying the foundations we've laid. So thank you.
Thank you, Mr. Thank you so much. Thank you.
Yes, sir.
Yeah, see you. Yeah.
Thank you.
See you on Saturday.
All right, thank you so much.
You put the assignments on the group chats for us to.
I just look at it here. Take a screenshot. create a table that looks like this. Or let me just take that screenshot and put them like you requested. So create this table.
Okay.
That's what create it. So while you're creating it, you might be running into one or two problems. You can reach out to other of your colleagues. There could be a part you know that others don't know, and there's also possibility that some others will be the one asking you for help. So that's just how it goes. What's not happening now? So thank you. Let's see on that Saturday. Bye for now.
Bye, sir. Thank you.
Thank you.
Okay.